Hey guys, I wanted to do a little extra graphing tutorial for you guys just because I know a lot of people have really been struggling with graphing and how to do it, how to figure it out. So we're going to talk through position versus time graphs and velocity versus time graphs for 8 different scenarios. These are in your review. So if you need help with them, you just go through this video with me and hopefully we'll get it down. So before I'm actually going to do the graphs that are on your review, we need to talk about 2 different things, okay? And those are the big 2 questions, okay? 2 questions. Every time you do a graph, doesn't matter if it's position or velocity, there's always 2 questions that your graph has to answer. These 2 questions are, number 1, is it going positive or negative? Is it going positive or negative? Okay, if it's moving positive, most people say that would be to the right if you're going horizontally, or up if you're going vertically. Okay, if it's going negative, that means you're going to the left or going down, depending on what type of motion you're talking about, the horizontal or vertical. So your big question number 1, is your object moving in the positive direction or the negative direction? The other big question that you have to ask is it slowing down, speeding up, or is it constant velocity? Okay, it's going to be one of those 3 things, okay? So those 2 questions are what you have to ask yourself about every single graph, okay? Doesn't matter the type of graph, doesn't matter what your motion is, those are the things you're looking at. Is it going positive direction or negative direction? And then what is it doing? Speeding up, slowing down, or at constant velocity? Those are the big things. All right, so now let's actually get into this work here. Oh no, I need to erase all of my stuff real quick because it's going to be in the way. All right, good and erased. So now we have moved on over to our graphs on your review. So the graphs on the review, the first one we're looking at, it tells you the answer to your 2 questions. So we'll know how to graph it based on the answer to those 2 questions. This one's constant velocity. You see that here, constant velocity graph. And our direction is positive, okay? So our first graph is position versus time. Now, if we're moving in the positive direction, that means we have a positive slope for our position versus time graph, okay? That means we got a positive velocity, so we're going to have a positive slope on position versus time. If you did not already know that, on position versus time, your slope is equal to your velocity, okay? Only for position versus time graphs. But if you got a positive motion, then your slope should be positive on position versus time. If you got a negative direction, like going to the left or going down, then your slope is going to be negative, going generally down. So this one has a positive velocity. We're going to be generally going up on position versus time. And then we've also got a constant velocity. Constant velocity means it doesn't change. And if the slope or velocity doesn't change, you have a straight line. So constant velocity is a straight line on your graph. A straight line in the positive direction looks like that. Simple enough. We got a positive slope. We're going up because our direction's positive. We got a constant velocity, so our line is a straight line. It's not curved. Now, we have to change our thinking in order to do velocity versus time. So velocity versus time is no longer talking about physical space. It's talking about the direction the object's going. So if that direction is positive, it ends up on the positive half of the graph. Okay, so your graph is split into 2. You got the positive velocity side and the negative velocity side. If we're at positive velocity, that means we start on the positive side. Okay? We're on the positive side. If my velocity stays the same, it just goes straight across. Okay? My velocity is not changing over time. It's staying straight. Okay? And it's on the positive side. So we've got a positive constant velocity. That's our graph set number 1. Now let's go look at graph set number 2. Really similar, except one of the answers to the questions changed. Question number 1, is it going positive or negative direction? This time, it's going negative. Negative is going to mean our position time graph goes down. We're going to need a negative slope in general, so that's going to be going down. And then constant means we're going to have a line because our slope is not changing. It's staying the same the whole time. So constant velocity in the negative direction just looks like this. It's a straight line going down. And then for the velocity versus time graph, you're doing the same thing. You've got a negative velocity, so it goes on the negative side of the velocity graph. And if it's constant, it stays the same, straight across, like so. Okay, so the only difference between these two was that we went from a positive side to a negative side. Okay, now let's try something a little bit different. Our new one over here doesn't exactly answer the questions super well, because our question wanted to know speeding up, slowing down, constant velocity, negative, positive, all that sort of stuff. And this one doesn't answer those very well because it says it's at rest. Okay, so if it's at rest, is it moving in the positive or negative direction? Well, it's not really doing either. It's not moving. So our slope there is going to be 0. If our slope is 0, we're a flat line. Okay, and basically that just means we're starting off somewhere. Sorry, I didn't mean to move that around. Starting off somewhere. This says at a positive position, so we're starting at a positive position. If we're at rest, we're not moving. Okay, line just stays straight, not moving at all. And then if we think about that in terms of velocity, if you're not moving, your velocity is a big fat 0. Okay, if your velocity is 0, you started off on your velocity graph straight up at 0, move straight across, because your velocity is not changing, it's staying 0 the whole time. So that's your rest in a positive position. For your rest in a negative position, we actually have to change our graph a little bit, okay? Because we don't have a negative position over here. So at a negative position, I go down here, but if I stay at rest, it stays the same spot. So flat is a rest. And then on my velocity, if I'm resting, my velocity is still 0. So I start at 0, stays 0 the whole time. Okay, it's the same as the other one that is rest. If you're at rest, your velocity is 0, and your position time graph is just a straight, flat line. Now let's get on down to the slightly more difficult stuff. We're going to look up at the next row of graphs. We've got this one that's speeding up in the positive direction. So looking at position time, positive. Oh, I keep moving things, and I don't mean to do that. Okay, positive means we're going up. Speeding up is going to be the interesting part. So if we're speeding up, we're going from slow to fast. That's the goal of speeding up. You're starting off slow and going fast. So we're going to start off slow. Slow is kind of flat. So we're going to start off flat-ish, but still going a little bit up because we're going in the positive direction. And then as time continues, I get fast, and fast is steep. So I make it steeper in the positive direction. So you can see we go from flat, which is slow, to steep, which is fast. So that is speeding up. And because we're going up, that makes it the positive direction. Now for velocity, we've got to think about it a little bit differently. If we're starting off slow, our velocity is a low number, okay? And our velocity is positive because we're going the positive direction. So it's got to be a low number on the positive side. It could even be 0. It could also just be slightly above 0, whatever you want. But over time, that number for velocity has to get bigger. So if you want to get to a bigger positive, you got to go like so. Okay, you're going up and to the right. As time passes, you go from a small velocity number to a large velocity number. That's speeding up. And because we're going the positive direction, it stays on the positive side. Now we're going to look at that same thing, speeding up, slow to fast, but go in the negative direction. So negative is going to mean we're going down. Negative is down. So we start off going slow. Slow is flat, but we're going to start off going flat, kind of down a little bit. And then over time, as we speed up, we get steeper, but going down in the negative direction, okay? So our graph has flipped over. We went flat to steep, but now we're going down in the negative direction. And then for velocity versus time, we're starting off slow. Slow is close to 0. We're going to speed up, but we got to be on the negative side of the graph down here, okay? So we need to get to a big negative number because that's fast in the negative direction. So it looks like that. It's just flipped from our other one. They are flips of each other. Now let's look at slowing down. Slowing down is going to be positive for our first graph here. So slowing down goes from going fast to going slow. But we've still got to be going positive, so we're going up on position time. So to start off fast, you can be going steep, but we're going up because we're going in the positive direction. And then to get slow, you flatten out. So we go steep to flat, but overall, our graph is going up, so we're going in the positive direction. For velocity, we're going to be on the positive side of the graph because we are in the positive direction, but we're slowing down. So we start off at a high velocity, somewhere up here, and slow down, get closer to 0, maybe even hit 0 over there. So it's slowing down, going from a high velocity to a low velocity, but we're on the positive side of the graph, so it's in the positive direction. And then our last one for this, slowing down in the negative direction. So we're still going fast to slow, which is steep to flat, but now we're going down. So we start off going steep, down, and then as time passes, we're going to flatten out, like so. So we went steep to flat, but our graph is going down this time because we're going in the negative direction. And then if we look at the velocity, we're going to have to be on the negative side because we're going in a negative direction. And slowing down starts off with a big negative number, okay, large number just on the negative side. And then it goes to a small number or back towards 0, okay? So that's just about all of the different iterations of graphs that you could have that have one motion going at a time, okay? There are some things that might have multiple sections, like your rocket problems, or some of your free falls. They could have multiple sections, but overall, these are the basic graphs. Now the last little section down here is about position versus time graphs and finding the velocity on them. I'm not actually going to do every single section here for you, but I will look at a couple of them. So in order to find velocity for position versus time, you're doing the slope of the graph. Slope equals velocity. And what you should know about slope is that it's equal to rise over run. So for each section, you got to do rise over run. But the issue that I see plenty of times here is that people count spaces rather than actually looking at the numbers on the axis. So you're gonna have to make sure that you do that. So if we look at section A, B, this one's really pretty easy. From A to B, you have no rise. It does not go up at all. So your rise is 0 divided by your run, which is 2 spaces, which is also 2 seconds. So you get 0 meters per second for AB, which we just saw in the graphs above. If it's flat line on position versus time, then it is 0. It's at rest. It's not moving. But let's go look at BC. So for BC, I gotta erase my previous rise over run real quick. Okay, for BC, your rise is down 2 spaces, but you can't put -2 because your 2 spaces actually represents 10 meters, okay? So your rise is down or negative 10 meters, and then your run from B to C is 2, and that is 2 seconds. So it's negative 10 divided by 2 is negative 5 meters per second. So on and so forth for the rest of the things. Okay, so just make sure when you're doing the slope on these, you are checking your axis to make sure you're using the numerical values there for rise over run rather than just counting the spaces. All right, guys, hopefully this clarified a few things on graphing. If you're still in the dark on how to do any of it, please let me know. I'll come help you out. We'll try to work through it, but you got to know this stuff for your tests, so make sure you're asking when you need it.